Welcome back. Before the break, we saw how to draw a line graph, and then we made the distinction between data that is continuous and numerical and data that is discrete. Very often this kind of data is actually qualitative data, and discrete data deals with whole entities or whole values that you cannot halve or make fractions of. Remember, I said you can't have red and a half. There are no fractions of that. It's either red or blue or green. So we're going to look at how you represent that kind of information on a graph. And it's a different kind of graph that we have to draw. It's a bar graph. Let's have a look at the bar graph, and let's focus on some of the issues that you need to be able to recognize and make sure when you draw a bar graph, you draw it correctly, because this is one of the kinds of graphs where often learners confuse the bar graph with a histogram, which we'll look at a little bit later as well. So here's our bar graph. It's showing the average rainfall in 6 provinces for 2 years. And instead of a line, we have our data indicated by a series of columns. Once again, same as what applied to the line graph, we have the dependent variable being illustrated on the y-axis and the independent variable on the x-axis. How do we distinguish between the two? Well, the thing that we don't know, that we're trying to find out, is what is the average rainfall. That's what we're trying to find out. What we can control is we're looking at that rainfall in the different provinces. So that is your independent variable, whilst the average rainfall that we don't know is the dependent variable. The axes, just the same as in a line graph, must be labelled and units given. Millimetres per year. There are no units for the provinces. That is just a title as itself, and it makes sense. There are no units for discrete data. There's no millimetres, kilograms, speed, or anything like that. It is just provinces. Each axis should be drawn with a ruler, divided into a scale and labelled. And so here we've got Gauteng, Mpumalanga, Limpopo, etc. All the different provinces. Up here we've got the rainfall, 50 millimetres, 75 millimetres per year, 100 millimetres per year. Now in a bar graph, we've said it a couple of times today already, the variable is discrete. It's very important that we remember that, and that means that we're going to see something interesting happening when we draw the graphs. Of course, it's important that your graph has a heading that reflects both variables, and when you draw the information, you're going to make sure that there is a space between the different bars. This is because there's no continuum between these provinces. There's a continuum when we're talking about kilograms, for example. 1 kilogram, 2 kilograms, 3 kilograms might be what you illustrated on your axis, and there's a continuum from 1 to 2, 2 to 3. But there's no such continuum between Gauteng and Mpumalanga. So we need to show a gap in the middle. We need to show that these bars do not touch and the columns work upwards. And here we show that we wanted to possibly compare the rainfall, and there we would either use color or provide a key to show the different rainfall in the different years. Let's have a look at another example of a bar graph. Here we have listed some of the elements on the periodic table, and we've calculated their boiling point in degrees Celsius. When we put that information onto a graph, we can see that we will have the unknown dependent variable, and here's the variable that we as the scientist are controlling. We're measuring the boiling points of sulfur, mercury, sodium, and phosphorus. Now there is no continuum between sulfur and mercury. You can't have sulfur and 3/4. It's either sulfur or not. So the information that is drawn in these on the bar graph in columns must not touch each other. There must be a gap between those columns to show that these values are discrete. You would plot the information, draw the information, use a ruler, make sure that the bars are neatly drawn and the same width. And it's not essential, but if you would like to, you can shade in the different bars in different colors. The next type of graph that we're going to look at is a pie graph, and I think it's wonderful where it gets its name from. It comes from a pie, and a pie is a circular item of food that we cut into segments or sectors. And in exactly the same way, a pie graph, if you have a look here, it shows us that the pie graph is cut into sectors or segments. And a pie graph is a complete circle, so therefore each segment is going to be a fraction of that circle. And sometimes it's very easy to calculate. Half of the circle must be 50%. A quarter of the circle is going to be 25%. But some of the sectors might become a little more tricky to calculate. And so when we come back after the break, I'm going to show you how you calculate the sectors for making up your own pie graph. You might want to get a piece of paper handy so that you can copy down the formula, so that when you're given a pie graph to draw, you are really going to be expert at doing this.